Today, I will explain several important concepts in chemistry, focusing on the periodic table and chemical combinations. These concepts help us understand how elements behave and how substances are formed. I will begin with the position of elements in the periodic table. The periodic table is arranged in rows called periods and columns called groups. The position of an element depends on its atomic number and electron arrangement. Elements in the same group have the same number of electrons in their outermost shell, and therefore show similar chemical properties. Elements in the same period have the same number of electron shells. This arrangement helps scientists predict how elements react and the types of compounds they form. Next, I will talk about iron formation. Iron is formed through nuclear reactions in the cores of massive stars. During stellar fusion, lighter elements combine under extremely high temperatures and pressures to form heavier elements such as iron. Iron is the last element formed through fusion because it has the most stable nucleus. When massive stars explode as supernovae, iron and other heavy elements are released into space and later become part of planets including Earth. I will now explain valency. Valency refers to the combining capacity of an atom. It is determined by the number of electrons an atom loses, gains, or shares during chemical bonding. For example, sodium has a valency of 1 because it loses 1 electron, while oxygen has a valency of 2 because it gains 2 electrons. Valency helps us determine how atoms combine to form compounds. Closely related to valency are radicals. Radicals are atoms or groups of atoms that carry an electric charge and act as a single unit in chemical reactions. They can be positively charged or negatively charged. Examples include the sulfate radical, carbonate radical, and ammonium radical. Radicals play an important role in forming chemical compounds. Using valency and radicals, we can write formulae of compounds. A chemical formula shows the types of elements present in a compound and the ratio in which their atoms combine. For example, magnesium chloride has the formula MgCl2 because magnesium has a valency of 2 while chlorine has a valency of 1. Writing correct formulae ensures that compounds are represented accurately. Another key concept is balancing chemical equations. A chemical equation represents a chemical reaction using symbols and formulae. Balancing ensures that the number of atoms of each element is the same on both sides of the equation in accordance with the law of conservation of mass. This is done by adjusting coefficients, not subscripts. A balanced equation shows that matter is neither created nor destroyed during a reaction. Finally, I will explain the role of electron arrangement in the development of the periodic table. The modern periodic table is based on electron arrangement rather than atomic mass. The number of electrons in the outer shell determines an element's chemical properties and its position in the table. This understanding helped scientists organize elements more accurately and explain trends such as reactivity, atomic size, and valency across periods and groups. In conclusion, the periodic table, electron arrangement, valency, radicals, and chemical equations are all closely connected. Together, they help us understand how elements combine, react, and form the substances that make up our world. Thank you for listening.